I recently learned about a Python library called Patito. And what fascinated me about this library is its ability to validate Polars DataFrames against a data model. Patito is built on top of Pydantic and follows much of the same model building framework, but it has specific application to data frame model validations. Now, we've discussed the importance of data quality on our channel before, but we've mostly only talked about schema validation and data types. Another aspect of data quality is the data itself. Should nulls be allowed? What specific statuses should be accepted? These are questions of data validation, which Patito can help with. So our use case for today is going to be that we have a request form with data that we need to map into a database. Before bringing the data in, we want to make sure we validate it. Now, good form design usually has data validation already built in. Even still, it doesn't hurt to have additional checks in your data pipelines. All right, so we have our Jupyter Notebook here. If you haven't already, be sure to pip install Patito. And if you want to get access to this Jupyter Notebook, we do have a GitHub repo. It's called Polars Code Academy, and we'll have that in the description of the video so that you can kind of navigate to that and download those files if you want. We provide both the Jupyter Notebooks and the data sets. So you can pause the video now if you want to go do that. Highly recommend so you can kind of follow along here. Okay, so we're going to start by creating our model. And to save time, we have actually already created the class and the model, so to speak. The first thing that we're going to do is import Polars as PL and then Patito as PT. Now we also need a few other things from the typing library, so we're going to also import literal and optional from that one. All right, so the next step is that we're going to declare the request class. Now we can do that by typing class and then request. And then within here, we're going to invoke a Patito model by typing pt.model. And again, keep in mind that this is built on Pydantic. So if you're familiar with that, it's very much kind of a similar type of look and feel for how you would do a Pydantic model. Okay, the final step is to add in the fields and data types that you want. And so what we're doing here is we've got, looks like 5 columns, right? We've got request ID, requestor, request type, description, and the request date. Now, after we declare those fields, we also need to have the data types. So you can see we have integers, strings, literals. This is an optional string right here. So if there's nulls there, it's not going to really matter. And then we also have another string for the request date. You'll notice that we also have some additional pieces from Patito that we're adding on. And so you can see up here at the very top, we've got pt.field, which is a function that allows us to add additional validation rules, right? So in this case, we're wanting to make sure that the request ID is unique. We obviously want to avoid any duplication there. So that's what that piece is doing there. And then this bottom one is also using that field function. But in this case, we're going to be changing the data type. And we're changing it from a string to a Polars data type. So pretty cool. You can pass in, if you have custom Polars fields that you want to use, you can pass that in and make sure that those are correct there. Let's go ahead and run this. And now we have our model. So now that we have our model built, we can actually call a bunch of methods and attributes off of it. Now, one of the more useful attributes you can call off of this class is to check the valid data types. Now, what that really means is it's going to look at and give you a list of all of the Polars data types that can be accepted by this model. So let's actually go ahead and run this so you can kind of see what that looks like. And you can see we were more broad here. Obviously Polars has custom data types that it can use. And within Pydantic and Patito in this case, we just passed in an integer. So what we're seeing here is, okay, yes, it's an integer, and these are the Polars data types that will work within that first field there. Now, if you wanted to be more specific there, we could come back up here and fix that. Let's actually just do that for fun. We're going to type dtype, and then we're going to set it equal to, and look, we get some nice stuff here. We're going to type pl.int, and then we're going to go ahead and just change that. And now when we run that, we are very specific as to what data types can actually be used from Polars. Okay, let's go ahead and import our data now. Let's go ahead and expand this. So nothing too crazy here. We have our model already, and we just want to import some data from this request.csv file. We're going to go ahead and do that. And then what we want to do is actually validate our model. So in order to do that, we're going to use a try and accept process. So we're going to type try, and then within that, we're going to try to validate our data frame against our model. So we'll type request.validate, and then we're going to pass our data frame in there. Now, if that's successful, we want it to print out that the validation was successful. So we have this line of code here that'll do that. If it wasn't successful, we want to throw an except and an error here. So we're going to call the pt.dataframe validation error, which is basically a nice printout of what the issue is. So it's going to tell us where in the model, or where in the data frame it doesn't match the model, which will be really handy for everything there. Okay, let's go ahead and just attempt to validate our data. All right, so we get 3 validation errors here. And the first 2 are very much related. So it's saying that we are missing a description column and that we have an extra column called description that's superfluous. Now, the reason this is happening is Patito is very specific when it comes to column names and everything like that. So since a better way to put that is it's case sensitive, right? So clearly we have a description and we want to use that, and we shouldn't be really having this error. But since it's a uppercase D in our CSV file, it's not matching with what we have in our model. So we'll have to go back and fix that. But first, let's take a look at the third error here. So this third error is the request date, and it's telling us that the Polars data type string does not match the model field, which is, if we go back up to our model, a little bit of ways up here. If we go back to our model, we see that we actually overwrote the data type to be a Polars date data type. So it's expecting that. All right, so let's scroll back down here, and we'll fix our data in just a moment. First thing that we're going to do actually to fix our data is come to our CSV file, and we're going to change this to a lowercase d. Okay. Now, you can change it on the model side as well. For our purposes, it's a little bit easier because then we don't have to, rerun the model and everything like that. I mean, it's really not a big deal either way. But again, the reason I'm doing it on here is it also kind of matches more with the CSV's kind of case conventions that it has here. It's got the lowercase and then the uppercase for the second words. So anyway, let's go ahead and fix that. And then the other thing that we need to fix is the data type. Now, we can do that by using the try parse dates parameter when we read the CSV file into Polars. And what that's basically going to do is it's going to try to match the pattern for dates. And if it does detect something that's within the CSV file that looks like a date, it's going to assign that as the date type. So let's go ahead and run this. You can see that we have our description updated here. It's now using the correct lowercase d on that description. And then it also has successfully parsed the request date column as a data type. Okay, let's go ahead and try to run this just one more time. All right, so this time when we run it, we get a validation successful message. So everything is good to go there. It matches the model, and we can now confidently bring this data into the database. Or if you're working on a data science project or whatever else, maybe you're building a machine learning model, you can check your data against these models and make sure that, yes, we are in fact getting some good, clean data. All right, so hopefully you can see how Patito offers a robust yet simple way to validate Polars data frames. And I hope that this video gave you a good introduction to Patito and its core functionality. There's obviously more that you can explore. And if you'd like to do that, you can go ahead and visit the documentation here. It's within this Jupyter Notebook file. All right, so just to wrap up here, if you have any comments or suggestions for other data validation tools, please share your thoughts in the chat. Otherwise, thank you for watching, and we'll catch up with you soon.